Okay, let's first talk about addition and subtractions of decimal numbers. So this example is 217.3 plus 72.567. So the most important thing for the addition and subtraction is we put decimal points on a vertical line. Decimal point for 217.3, decimal point for the 72.567, and another decimal point for the answer. So from this part of the picture, this slide, you can see there is a vertical line of decimal points. So after you put the vertical line, we put the numbers before and after decimal points. 217 before the point, 3 after the point, 72 before the point, 5, 6, 7 after the point. And then you just add vertically. So these two places are empty, we put zeros. 0 plus 7, 0 plus 6, 3 plus 5, 7 plus 2, 9, 1 plus 7, and then bring down 2. So this is the addition. Subtraction is the same. So we use the same numbers. 217.3 minus 72.567. First, we draw the vertical line of decimal points. It's 3 decimal points. And then we put 217 before the point, 3 after the point. 72 before the decimal point, 5, 6, 7 after the decimal point. So now it's a subtraction. So again, for the empty place, we put 0. So now 0 minus 7 is too small. So this 0 become a 10. And then this 0 become a 9. This is 3 become a 2. 10 minus 7, 3. 9 minus 6, 3. 2 minus 5, still too small, so we need to do it again, borrow again. We got a 12 here, and then this 7 becomes a 6. 12 minus 5, 7. 6 minus 2, 4. And then change 1 to 11 here. And number 2 become number 1. 11 minus 7, 4, bring down 1. So the answer is 144.733. So the most important thing again is this vertical line of decimal points. So you make this line first, and then put numbers before and after that, and then subtract without decimal points. Now let's look at multiplication questions. So if you want to multiply two decimal numbers, we have 2 steps. Step 1, we just multiply without decimal points. So for this 2.4, if you delete decimal point, this is 24. 0.33 without decimal point, this is 32. So step 1, we use 24 times 32, we got 768. There's no decimal points here. In the first step, when you multiply, there's no decimal points. After first step, we count how many places, the total number of decimal places. So 2.4, how many decimal places we have? 1. And the second number, 0.32, how many decimal places we have? 2 more, so it's 2 and 3. So we have 3 decimal places. So now in the answer, in the product, we want same number of decimal places. So 2.4 times 0.32 is 768 with 3 decimal places. When you count the decimal places, we will count from right to left. So these 3 numbers, they are all in the decimal part. So here's the decimal point in the answer. So it's 0.768. Or you can just say it's 0.768. Now let's look at 3 more multiplication questions. So step 1 for all these 3 questions are the same. Step 1, we look at all these multiplications without decimal points. So it's 24 times 38, which is 912. And now for each question, these 3 questions, so we count. Step 2, we count the total number of decimal places. So for the first question, 2.4 has 1 decimal place. Multiplied by 3.8, we have the second decimal places. So 9112, we need 2 numbers, 2 digits in the decimal part. So this is the decimal point. We have 1, 2. These 2 digits in the decimal part. So the answer is 9.12. So the second question, in the first number 24, we don't have any decimal places. But in the second multiplier, we have 2 decimal places. So that's why we have the same answer, 912 with 2 decimal places in the answer. So 1, 2. So 12 is in the decimal part. So for both of them, we have the same answer, 9.12. The last one, we have a lot of decimal places. So let's count them. In the first number, we have 1, 2, 3 decimal places. And then we have 4 and 5 decimal places. So in the answer, we need 5 decimal places. 912, we only have 3 numbers. How can we get 5 decimal places? We add zeros before the number, before the answer, before the result of step 1. Okay? So we got this 912 from step 1, multiplication without decimal points. And then we count 5 decimal places now. 1, 2, 3, 4, 5. So these are the decimal parts. Where's the decimal point in the answer? Here. So the answer is 0.00912. Okay, now let's look at this division question. Division is the hardest part in this chapter. So step 1, we need divisor to be a whole number. We will change the divisor to a whole number. How can you change 0.53 to a whole number? We move decimal point twice, 1 and 2. Then we got 53. So we move decimal points in the divisor 2 places to the right. So to keep the quotient, we have to move decimal point of both numbers, both dividend and divisor. So you cannot only move 1 decimal point, we move both. We move this decimal point 2 places to the right. 1, 2. So we also move the decimal point in the dividend 2 places to the right to get a new division. What's our new division? 662.5 divided by 53. So 53 is the whole number we need. After you got a new integer divisor 53, we need to do the long division. So step 2 and step 3 is much harder. First, we do the long division. We put the new dividend inside and the 53 outside. To be safe, because sometimes dividend is smaller, so we add some zeros. How many zeros? Normally I add 5 zeros, just to be safe. So now I'm going to divide without decimal points, so I will pretend that there's no decimal point. It's a long division for two integers now, a very big dividend here, and the divider is 53. So first, 66 divided by 53. So we put 1 here, 53, and then we got 1, 3. Bring down number 2. Bring down number 2. 132 divided by 53. So we got the quotient 2 here. 2 times 53 is 106. And then we assume there's no decimal point. Okay, so we got a subtraction. 132 minus 106 is 26. Bring down number 5. 265 divided by 53. We got the quotient 5. And now we got remainder 0. So remainder 0, you stop. So this is step 2. Okay, it's a long division, again for integers. We just pretend that there's no decimal points. So the last step, we will look at the decimal point. We put a decimal point on top of the decimal points. So there is a decimal point in the dividend. We move it up to put a decimal point in the quotient. Okay, put the decimal point on top of it. So the answer is 12.5. So first step, we get an integer divider 53, and then second step, we divide without decimal point, and then we put decimal point on top of decimal point. This is the division. Let's look at another division example. 1 divided by 2.5. So what's our goal? First step, we want this one to be a whole number. Dividing by a whole number. So the second number, the divider, is a whole number. So we want to change 2.5 to a whole number. We need to move decimal points 1 places to the right. 1 place to the right. And remember, we have to move both decimal points to the right, same amount. So this decimal point moved to the right 1 place, and where's the decimal point in number 1? So it's 1.0. You move it 1 to the right, you got a number 10. So we got a new division, 10 divided by 25. That's our step 1. Step 2, it's a long division. Our new dividend and the divider is 10 and 25. So 10 is too small to be a dividend. So we will add 5 zeros. So here is the decimal point. And then we will add 5 zeros in the right. So now if you forget about this decimal point, you get a very big number. 1, 2, 3, 4, 5, 6, 7. So this is 1 million. So it's not 10 divided by 25, it's 1 million divided by 25 now. So now it's in the long division. 100 divided by 25, we got quotient 4. 4 times 25 is 100. 100 minus 100, remainder 0. So remainder 0, you can stop. You don't need to bring down all the other 4 zeros, because it's still 0. So this is the step 2. It's a long division without decimal point. After you add 5 zeros. The last step, step 3, you put a decimal point on top of this decimal point in the dividend. So the quotient in the answer is not 4, because there is a decimal point here. So it's 0.4. 0.4 is the answer. Okay, so now let's talk about rounding off. So sometimes we have to round off a given number to a particular space, a given place. So there is a given place. So for example, the first example, the given number is 26.03. Okay, so we want to round this number to the tens place. Okay, where's the given place here? Tens place. Where's the tens place? Okay, so this place is the given place. Okay, so we want to get an answer. Stop at this given place. So we don't need this number 3. Okay, so how to round off? This number 3 also have a name. This number 3 is called the right neighboring digit. So this number 3 is the right neighboring digit of the given place. So if this place, so the right neighbor, is less than 5, then you just delete it. If the right neighbor is greater than or equal to 5, so the given place plus 1. The number in the given place plus 1. So in this example, the first example, 3 is less than 5. 3 is less than 5. So you just delete this number 3. You got the number 26.0. You cannot write down 26 because you need to keep a number in the given place, tens place. What's the number in the tens place? 0. The second example is 26.07. So we still want to round this number to the tens place. So this is the given place, G, given place. And the 7 is in the right neighboring digit, right neighbor. So 7 is greater than or equal to 5. The given place will be increased by 1. So you will got 26.0 plus 1 is 1. So the answer is 26.1 for the second example. Okay, now let's look at more examples. So first you find the given place, tens place, so this is number 1. This is the given place. So what's the right neighbor? 8.123. So this number 2 is the right neighbor of the given place. 2 is less than 5. So you just need to delete everything after the given place. So the answer is 8.1. Question B. So where is the given place? The given place is 10,000s place. So 10,000s. This is 10, 100, 1,000, 10,000s. So this 6 is the given place. 5 is the right neighbor. Okay, 5 is the right neighbor. 5 is greater than or equal to 5. So what's the answer for question B? So let's put it here. 8.9076523 is, after rounding off, you keep everybody before the given place, number 6. And then because 5 is greater than or equal to 5, this number, the given place, will be increased by 1. So you put a 7 here. After rounding off is 7. And then every number, all the numbers after the given place will be deleted. So you can finish other questions as exercise. So we will talk about decimals, fractions, and percents now. First, let's talk about the relation between decimals and fractions. Okay, so if you are given a decimal number, given this 26.03 is a decimal number, how can you get a fraction? How can you change this number to a fraction? The rule is very simple. So first, for fraction, you need numerator. Just delete the decimal points. Okay, right here. Delete decimal point, you get a numerator. 26.03. Delete decimal point, we got 2603. And then the place value of the last decimal digit is the denominator. So where's the last place? Here. So what's this place? 100 is place. So what's the denominator? 100. Okay, so the last place give us the denominator. So 260.3 is 2603 divided by 100. Let's look at the other example. This example. So numerator, without decimal point, we got 2101. We just delete the decimal point. What's the last place here? The last place is 1000th place. So denominator is 1000. Okay, so it's very easy to change decimal to fractions. You just remember this rule. Okay, just remember this rule. The rule here. Okay, so now if you are given a fraction, a over b, how can you get a decimal answer? How can you change fraction to decimal? You use a division. Okay, the division which has decimal answers. So let's look at 1 divided by 5. 1 divided by 5. Where's decimal point? So 1 is 1.00000. We add 5 zeros. And then 5 is outside the long division. So now we forget about this decimal point in the long division. So it's 10 divided by 5. We got 2, remainder 0, stop. So what's the answer? The last step, you put decimal point on top of decimal point. So the answer is 0.2. So we change this fraction to a decimal number 0.2 by the division. The second example is a little bit harder. 21 over 25. So division is 21 divided by 25. So what's 21 divided by 25? We will do it here. We know the answer should be a decimal answer, so we put a decimal point inside the dividend. Add 5 zeros. Okay? Make it a very big number inside in the dividend if you forget about this decimal point. So now it's not 21 divided by 25, it's 210 divided by 25. What did we got first? We got 8 here. 25 times 8 is 200. 210 minus 200, we got 10. Bring down this 0, 100. 100 divided by 5, 25, we got 4. So remainder is 0, you can stop. If the remainder is not 0, you just keep adding 0, continue the division. The last step, we put decimal point on top of decimal point. So what's the answer? 0.84. So we change fraction to decimal by division. You put decimal point first and then add some zeros and then divide. So sometimes you get a mixed number. Mixed number is not harder because this 3 just means integer 3. So the fraction part, you use division. This proper fraction, 1 divided by 5. You got 0.2, and then you just put this integer decimal part together, you got 3.2. So it's not harder. Now let's look at the third part, percent. So we have decimals, fractions, and percent. What's the definition of percent? So this is a notation. What this percent means? This percent means over 100. Okay, if you have some p%, this means p over 100. So here's the example, 97%. Percent means over 100, so 97% is 97 over 100. If you use division, 97 divided by 100, you will get 0.97. If it's 150%, again, this notation of percentage means over 100, so we got 150 over 100. And 0.5%, this means a 100 in the denominator, so it's 0.5 over 100. 0.5 divided by 100, you got 0.005. So maybe I will try the last division. What is 0.5 divided by 100? It's not very hard. We add 5 zeros or some zeros and then pretend that there's no decimal points. And then we do the long division. So here's 100, so we need 500 to start. 500 divided by 100, we got a 5. 5 times 100, 500, and then remainder 0, you stop. So the long division is very short. So you have to pay attention to where you put this quotient 5. You use 500, so quotient 5 is in the last column here. Last column of 500, the ones column of 500, you put quotient number 5. So what about the two places before that? We put zeros. If you need, you can put more zeros. Okay, yeah. So from long division we got a 5. The last step, we put decimal point on top of decimal point. So here is the answer. It's 0.005. This answer. It's a long division. Okay? Yeah. Now we know the definition of percent now. So now we know 3 things. We have decimals, fractions, and percents. Okay, so if you're given a percent, we will change it to decimal, and then we change decimal to fractions. Okay, because the rule from percent to decimal, a decimal to percent is much easier. It's very easy. Okay, it's very easy. What's the rule? We just move decimal points 2 places to the right or to the left. So if you are given a decimal number 0.68, how can you change this to a percent? You just move decimal points 1, 2, 2 places to the right. You got 68, and then you add a percentage notation because you know we want a percent. You just move decimal points 2 places to the right. 2.05, 2 places, you got 205, 205%. And this one you got 70.8%. 1.4, you move 2 places. 1.4, you move 2 places, you got 14, 1 place, another place is empty, so you got 140, and then you put percent, so it's 140%. The last example here, you move it twice, you got 0.67%. Okay, so if you want decimal to percent, you move 2 places to the right. So now if you are given percent, you want to get a decimal, you just move 2 places to the left. Move it back. So let's look at 68%. You want to get a decimal answer. Okay, so where is the decimal point in 68%? It's here in 68. So now we move 2 places to the left. You got 0.68. That's the answer. You find decimal point, move it to the left twice. So now let's look at 70.8%. Change this to decimal, move it to the left twice, you got 0.708. Okay, you just move it to the left. 2 places to the left, you got the decimal answer. So that's the relation between decimal and percent. And we already know how to change decimal to fractions and fractions to decimals. So we can change between these three things. Okay, so now let's look at an application. So how can we compare decimals and fractions? So the idea is we change all of them to decimals, and then we can compare the digits in the decimal places, right? So you can compare 3.45 and 3.4444. Which one is bigger? So the first two digits, they are the same. So you compare the third one. Hundreds place. Here is 5, here is 4. So this is bigger. Okay, the last number is 3.5. 3.5 is bigger because the second place. This 5 is bigger than that 4. Then we know the answer is the largest fraction, 7/2 is bigger than 3, and 4/9 is bigger than, sorry, this is wrong. Is bigger than 3.45, and then is bigger than this, makes the number. Okay, so the idea is we change all the fractions to decimals, and then we can compare decimal numbers. So now the problem you may have is how to get these decimal numbers. So let me repeat the division part. Change fraction to decimals, we need division. 7/2. So this is 7 divided by 2. Right? Okay, long division, 7 and 2. We put decimal point, we put some zeros. 7 divided by 2. So here is 3, 6, subtraction, we got 1. Bring down 0. 10 divided by 2. We pretend there's no decimal points here when we divide. Okay. 10 divided by 2, 5. And remember, the answer is not 35 because we have to put a decimal point on top of the decimal point. So the answer is 3.5. Okay, so the other one is a little bit harder. 4/9. 4/9 is 4 divided by 9. So again, we put decimal point inside and then put 5 zeros. 9 is outside. And then we pretend there's no decimal points in this long division. 40 divided by 9. We got a 4 here. 4 times 9 is 36. 4. And then we bring down 0. 40 divided by 9 again. So we got 4 again. 36 again. And then we got 40 minus 36, 4 again. We'll bring down another 0. 40 divided by 9, 4 again, 36 again. So this procedure will continue forever. So what's the answer we will get? Is a lot of number 4 on top and never stop. So what's the answer? We put decimal point on top of the decimal point. The answer is 0.4444 and never stop. And then we add the mixed number part, the whole number part, 3 before the quotient. Okay, so you change all fractions to decimals and compare decimal numbers. The last part in this chapter, we will talk about scientific notation. Okay, scientific notation. What is the scientific notation? It is the number a times a power of 10, 10 to the nth power. So there is a restriction for this number a. A is between 1 and 10. A could be number 1, but not number 10, strictly less than 10. So for any number, we can change it to decimal, and then we can change it to scientific notation. How to change the number to scientific notation? First, let's write down the rules for this a. Okay, so how to get a? We put decimal point after the first non-zero digit. To get a. So let's look at the first example here, this example. 0.0023. We want a times 10 to the nth power. So how to get this a? We put, this is the first non-zero number. We put decimal point after this number 2 to get a. So we copy the given number without decimal point. And then we look at the first non-zero digit. We put decimal point here between 2 and 3 after the first non-zero digit. So our a is 2.3. So now what's the exponent n? How to find this n? Okay, n is the moment of the decimal point. N will change a to the given number. Okay, so we will change this number to the given number. We'll change a to the given number by moving decimal points. How to move it? You see, in the given number, this is the decimal point. It's between the first two zeros. In a, the decimal point is between 2 and 3. So we will move the red decimal point to the left 3 places. Then we will get a new decimal point between the first two zeros. Then you will get the given number. So this number n is the movement of the decimal point. Of the decimal point. In a, we move the decimal point in a. So if you move to the left, it's negative. If you move to the right, it's positive. So this is -3. Okay, so now let's jump a little bit. Look at this example. 8,560. How can we change this to scientific notation? Okay, so first a, we put decimal point after the first non-zero digit. So first non-zero digit is 8. Okay, start from the left. First non-zero digit, and then we put a decimal point here. So our a is 8.560 times a power of 10. Okay, so what's the n? How to get it? N is the movement in a. We will move decimal point in a to get that number, 8,560. How can you move it? How can you move the decimal point? We'll move decimal point 3 places to the right. 1, 2, 2, 3, then we got 8,560. So move to the right is positive, and then how long you moved? 3 places, so n is 3. So this is the movement of decimal points in A. Okay, so move this way, move to the right, n is positive, move to the left, n is negative. Another example. Let's look at 102, this example. Okay, 102, we want to change this to a times 10 to the nth power. So 102, first and zero digit is this number 1. So we put the decimal point here. We got a is 1.02. Okay, so n is the movement, and we'll change this a to 102. So we have to move decimal point to the right 2 places. So this is 2, n is 2. Move to the right 2 places. Okay, so we move decimal points in A 2 places to the right. We got the given number 102. That's how we change any number to scientific notation. Let's look at the bottom question. So this is 8 million. It's a big number. How can we change this to a scientific notation? First, A is easy. Right? We just put the decimal point after the first non-zero digit 8. So our A is 8. 8 point, a lot of zeros, so it's still number 8. Times the movement. So we will move this decimal point to get 8 million. So we have to move it this way. How many places? 6 places. So n is positive 6. So it's 10 to the 6th power. Now let's look at 2 tricky questions. These 2. So you want to change number 1 to a scientific notation. So what's our A? We look at 1, 0. We put the decimal point after the first non-zero digit. So our A is still number 1, 1.0. So now what's the movement? N is the movement of decimal points in A to the given number. This is the given number. So they're the same number, so we don't need to move n. We don't need to move at all, so n is 0. N is 0 means no movement. So here is 0 power. N is n. N is 0, sorry. N is 0. Another tricky question is 10. How can you change 10 to this scientific notation? Okay, so we look at 1 and 10. So we put decimal point after the first non-zero. Okay, so this is the first non-zero digit. We put decimal point here, between 1 and 0. So our A is 1, or 1.0. What's n? N will change 1 to 10. So you'll move decimal point 1 places to the right, so it's 10 to the 1st power. N is 1. So the last example, I'm going to explain a multiplication of scientific notations. So this is the scientific notation. This is another scientific notation. So it's a multiplication of 2 scientific notations. So first we put 2 a's together. Okay, so 1.5 times 8, we got 12. Multiply, multiplication of decimal numbers. And then the second part, second part is power of 10. So what's the rule of multiplication for power of 10? So if you have 10 to the mth power times 10 to the nth power, we add them. We add the exponents. It's m plus nth power. So here is 10 to the 12, 10 to the negative 5th power. So this will be 10, 12 plus negative 5th power. So this is 10 to the 7th power. That's how we get this answer, 12 times 10 to the 7th power. But you have to be careful. This is not a scientific notation. Okay, it's not a scientific notation because 12 is too big. Remember, what's the condition for A? A has to be between 1 and 10. 12 is too big. So we have to change 12 to scientific notation. We need A times 10 to the nth power. So what is A? 12, we put decimal point after the first number 1. So it's between 1.12. So A is 1.2. And then what is N? N is the movement. You change 1.2 to 12 by moving decimal point to the right one place. So N is 1. Okay, so we got this. 12 is 1.2 times 10 to the first power. So finally, we have to put them together. 12 times 10 to the 7 is our new scientific notation for 12. So it's 1.2 times 10 to the first times 10 to the 7. And then we need this formula again. Multiplication rule for the power of 10. So we add 1 and 7 here. So it's 1.2 times 10 to the 1 plus 7th power. We got the final answer 1.2 times 10 to the 8th. So multiplication of scientific notation is very hard. After you multiply decimal parts, A parts together, and the power of 10s together, you have to check whether you got a scientific notation. If it's not, you have to change it to scientific notation.